Hello and welcome to another video from the OCI GCSE Computing course. Today we're looking at topic number 10, which follows on in this chapter of data representation. We're looking at how characters are represented by computers. So a character is a unit of information, and usually this means it's either a letter, a number, or a symbol. So for example, a hyphen is a character, this letter is a character. It's quite a general term, but as we looked at before, everything used by a computer needs to be represented in a binary format. That's just how it works. So if we as the user want to either input or have an output of characters, we need a coding system that decodes and codes characters to binary and back again, and this is done using what is known as a character set. So let's define this. A character set translates a character into binary code. So every character has got an associated binary code, and the binary code will vary character set to character set. There are a few, there's not like loads, but different countries will use different character sets for different uses, as we'll look at on the next slide. So it doesn't really matter which character set is used, but whichever the computer recognizes, it's what it uses for everything. So the hardware and software recognize what the character set says, and that's important. So the spec gives two examples of what you need to know. I think you need to know a bit more about ASCII than you do for Unicode. And ASCII stands for American Standard Code for Information Interchange. I don't think you need to learn that. For AQA you do need to learn that, but I don't think for OCR you do. They're not that mean. So it's based on the English language ASCII, and it represents 256 specific characters as 8-bit binary numbers. So this is an ASCII table, so it's a bit small, you don't need to learn it. For every character, it's got the hex equivalent here, and then this will be translated to binary. So, for example, in an exam, they may give you an excerpt from an ASCII table. This is actually taken from an exam paper. This little table, and it asks you to do something like write down how BAC would be represented in ASCII, and literally you'd list these in order. So you do B first, list this binary number, and without a comma, you just literally add on this to the end and then this to the end. You don't add them together like actually addition, you just literally add them onto the same line. Really simple, not that hard. So one thing to add, this slide originally said that this is 156 or 166 specific characters as a 7-bit binary number, but I looked at a few exam papers, and for whatever reason the exam board prefer you to speak about this. I think I saw that they did allow you to talk about 7-bit binary numbers because this is ASCII extended. 256 characters is the extended version of ASCII, so like an update of ASCII, but 7-bit was the original, and I would tend to go with that, but your exam board want you to do 8-bit, or think of it as 8-bit, so do that. And what this means is, an 8-bit binary number literally means that every character has these 8 bits associated with them. So there's one huge limitation of ASCII, and that is that no extra characters can be added to it. The base 156 or whatever, or 256 characters, they can't suddenly add to it because it's already been 8-bit. You can't, with 8-bit numbers, so in this representation, it can't represent more than this many characters. There aren't as many combinations. So because it's based on the English language originally, other languages such as Arabic, which use completely different letters and symbols, can't use ASCII, which is unfortunate, clearly, which is why they have to use other character sets such as Unicode. So Unicode is an addition to ASCII. It's like a developed version because it uses the first lot of characters that ASCII does. So it's based, as opposed to 8-bit, 16-bit, so 2 bytes. This is 1 byte. Although updates have increased this. So again, I had this originally at 27 bits, which I believe is the latest update, but your exam board said 16 bits in one of the exam papers, so I'll go with that. And that means it can represent at least 2 to the power 16 characters, because we go 2 again and again and again up until 16, and that's over 65,000. And if at 27 bits, I think it's over 1 million, so quite a big difference. And many of these characters aren't actually registered, but what it does mean is it does mean other characters are used in different languages and used by different people can be added. So Unicode is much more complete and it satisfies everyone. That's the point of it. So yeah, that's it for today's video. Looking at images next. quite an easy set of exam questions for this. You mainly to compare ASCII and Unicode, but mainly because ASCII is limited because it's only got a set amount of characters, whereas Unicode is more unlimited because it has uses a greater number of bits to represent each letter. But that's it. Thanks a lot for watching, and hopefully I'll see you in the next video.